the next question on mechanical engineering CTA question number 79. Again it is related to the vibrations. In this particular one, two heavy rotors are mounted on a single shaft. Considering each of the rotors separately, the transverse natural frequencies are 100 cycles per second and 200 cycles per second respectively. The lower critical speed will be. So this is a problem which is basically from the Dunkerley's method of combined frequencies. So what is Dunkerley's method is, it is an approximate method to find the combined natural frequency in this particular one. So this we can say it is an approximate method to find combined natural frequency So as per Dunkerley's, it is given as 1 by f square is equal to 1 by f1 square plus 1 by f2 square, where f1 and f2 stand for natural frequency when only one rotor is taken, f2 is the natural frequency when only the second rotor is taken into consideration, where f stands for, it is the combined natural frequency when two rotors are kept on the same shaft. That means if you have taken a shaft with two rotors, let us say if you are mounting only one rotor, then its frequency will be f1. When you are mounting only second rotor, then its frequency will be f2, and when you mount both the rotors together on this particular one, then it would be equal to f. And this is the Dunkerley's method, and where he has given the f1 and f2 in units of cycles per second, that is in hertz. So but the final answer he is asking in RPM. So if I want to get its value in RPM, it is f, which is in cycles per second, into 60 will give you RPM. So the basis for solving this particular question is, it's very simple question. So where he has given that two rotors are mounted on a particular shaft, and what is its combined lowest natural frequency, and when you try to take this, so it is a simple substitution. f1 is given as 100 cycles per second and f2 it is 200 cycles per second, then you can get 1 by f square is equal to 1 by 100 square plus 1 by 200 square. So probably you require a calculator, obviously you require a calculator. So if you go by this particular one, and f approximately, which is equal to f into, or you can say f is square root of 100 square into 200 square divided by 100 square plus 200 square, and maybe the simple difficulty in this particular one is, the difficulty is not in the way of the problem, but the difficulty is without calculator getting this particular value. And if you get its value, 60 into f is equal to, it is given as 5367 RPM. It happens to be equal to 5367 RPM, and the answer for this is D. Answer for this particular one is D. So the difficulty is not in the problem, but the difficulty is in the simplification process. Probably one has to make a simplified one approximated to this one. So one good thing in this particular one is the results are not close. So even you get an approximate value, it can be decided that this is the answer for this, because the other values, A is 12,000 RPM, which is far away from this, 9,360 is also far away from this, 8,465 is also far away from this. So obviously the nearest value, even without going for calculator, you can approximate it to be, or select it the answer as D, and the answer for this particular question is D.